So today we're going to be doing simultaneous equations. And one of the most important things about simultaneous equations is really understanding why we have them and what they are. So the very first thing I'm going to do is just look at this. What are simultaneous equations and what are they used for? And the reason is just simply to answer any problem where we have two things that are not known. So two like variables, they're called, that are not known. Normally when we solve an equation like 2x plus 3 equals 5, we would only have one thing. The only thing we didn't know is x, so there's only one thing to find out. But when we've got simultaneous equations, it's because we've got two things that we need to find out, okay? So here's an example of a simultaneous equations problem we're going to look at today. And I've put it in words because I think it's easier to understand if we have it in words. So in this example, we've got Jack bought 2 pails of water and 1 bottle of vinegar for £5.50. Jill bought 3 bottles of vinegar and 1 pail of water for £6.50. And then the problem is just finding out how much each costs. So how much is 1 pail of water and how much is 1 bottle of vinegar? So the problem with this is that we've got two things we don't know. We don't know how much water is and we don't know how much vinegar is. So we need two equations to solve that. We cannot actually solve this with just one equation. It's not possible, and I'll show you why in just a moment, okay? So you might be able to figure this out just in your head, and that's great. But we are going to learn an algebraic method because that method is really important that we can apply then to more challenging problems. Okay, and the first thing we need to do is we need to be able to write the equations from a problem like this. So what are our unknown things? The things we don't know are that we don't know how much water is and we don't know how much vinegar is. So we need to give an unknown, give a variable to those two things. So I've just gone really basic and I've chosen water to be W. And then with vinegar, I've chosen vinegar to be V, okay? So 1 pail of water is going to be represented with the letter W. 1 bottle of vinegar is going to be represented with the letter V. So putting that into an equation now, let's have a look at the first sentence. We know that Jack bought 2 pails of water and 1 bottle of vinegar for £5.50. So we can pop that into an equation. We've got 2 pails of water, so that's 2W, because water is W. And 1 bottle of vinegar, so that's 1V, because V is vinegar, costs us £5.50. And making that a little bit nicer algebraically, we've got 2W plus V is 5.5, okay? So that second equation there is simply a nicer version of the first one. They are the same thing, okay? We've just got rid of that one, don't need the one there for 1V. We don't need that 0 there, it doesn't have any point, there's no use there. So our first equation from that little problem we had is 2W plus V is 5.5. And I talked earlier about how we cannot solve this, okay? On its own, it can't be solved. It could be sort of an infinite number of answers, I guess, in a way. We could have loads of different numbers for W and V, where 2 times W plus V will equal 5.5. So on its own, we can't say exactly what W and V are going to be. So that's why we need the second equation. We need a second part of the problem. And the second part of the problem is that Jill bought 3 bottles of vinegar and 1 pail of water. So the vinegar and the water cost the same. They bought them from the same place. Okay. So this time we've got that 3 bottles of vinegar, that's 3W, plus 1 pail of water, that's, sorry, 3V plus 1W is £6.50. And again, we're just going to neaten that up. 3V plus W is 6.5. So now we've got a second equation from that second piece of information, okay? So what has happened is this problem that we started with has now become this mathematical problem with 2 separate equations. We've got that 2W plus 1V is equal to 5.5. And we've got that 3V plus 1W is equal to 6.5. So now what we have done is we've taken this problem and we've turned it into a sort of mathematical algebraic set of equations, set of simultaneous equations there, okay? Anyone got any questions on like, what are they and why are they useful? Okay, All right, so we will move on to how to solve them now, because this is the part that we really need to learn for your GCSE maths. How do we solve simultaneous equations? And there are actually quite a few methods. There's 3 methods that you will need to learn to solve simultaneous equations, okay, for your GCSE. By substitution is often the first one that you will learn. For most people, it's actually the first one that you learn, and you might learn it in a lesson in school or in whatever, wherever you're learning, and then you probably won't come back to it ever again, unless you take sort of a higher level GCSE or you go on to A level. It's unlikely that you would really use that again. So I will look at it, not today, but when we're doing a recap of all the algebra, I will do one problem. I'll do a couple of problems where we can look at the higher level with quadratics for this. But generally it's not very used very often. So the one that we will learn today is by elimination. And this is the most common method at GCSE. You'll almost definitely have to use this in your GCSE exam. Okay, so this is the one I want to concentrate on today. And then the other one, which we'll come to when we do graphs and stuff, is graphical methods. And again, that will come up in your GCSE. It's very unlikely. It's actually a much easier way of solving simultaneous equations as long as you're confident with graphs. And if we have time at the end today, I would actually like just to show you a little bit of how they link in. But we're going to concentrate today on the elimination method. So let's do it. Let's start learning how to do simultaneous equations by elimination. Elimination just simply means getting rid of one of the variables. So use the method of elimination to solve the simultaneous equations 4x plus 2y equals 26 and 2x plus 2y equals 20. Okay, so we've got these two sets of equations, or these 2 equations. We've got 2 variables we need to find out, their x and their y. And x and y are going to be the same thing in both. And we're going to use this to find out what they are, okay? And what you can see here is we've got exactly the same thing in both of these. And I've done this on purpose here. So we've got 2y in both of these equations. That won't always be the case, but it's just sort of the easiest thing to start with. And so when you have got 2 that are exactly the same, so for example, one number in front of one of the letters is the same in both, then we can just simply follow the steps, these steps. And the very first step, I'll try and do it. Let me just get my annotation on. I'll do it as we go, hopefully, if the PowerPoint lets me do that. The very first step, and it is quite important, is to number the equations. So I'm going to call this one equation 1 and this one equation 2. Okay. That's simple. And then the next thing that we're going to do is to subtract one from the other. So we can only do this once we have 2 that are the same. If you try and do this when you haven't got 2 of the same variable, it's not going to work. You're not going to eliminate a variable, and we'll look at what to do in that case after. But from now, I'm just going to basically subtract equation 2 from equation 1. So I'm going to do equation 1 minus equation 2. And I'm just going to do that by taking everything away. So as long as I take everything away in the second equation from the first equation, then it will work. So I will have 4x minus 2x is 2x. And you'll see here that 2y minus 2y is nothing. So that actually just goes away. I could put plus 0 there, but it's not essential because that's just gone away. And then here I've got 26 minus 20. And so that's just 6. Okay. So my problem now has just simply become 2x is equal to 6. And if I know that 2x equals 6, then I can solve that and say, well, x must be 3. Okay. Which I think was step 3. I've just gone ahead. So step 3 then is to solve to find x there, okay? I'm going through this quite quickly. Please just feel free to stop me if you have any questions. Okay, so now we know what x is. We can use x to now find what y is, because once we know one, we can find the other. So I can now take my value of x and I can substitute it into one of the equations and solve to find y. And it doesn't matter which one I choose, actually. I can substitute either into equation 1 or into equation 2. Looking at these two equations, equation 2 looks very slightly simpler, easier to work with than equation 1. So I'm going to go with equation 2. So I'm going to substitute into equation 2 there. So now I know that x is 3. I've got 2 times 3, 2x, plus 2y is equal to 20. Okay, now I can solve this. So that solving equation skills that we learned a few weeks ago is coming in useful here. 6 plus 2y is equal to 20. Subtract 6 from both sides. We've got 2y is equal to 14. And divide both sides by 2, y is equal to 7. So now we've found out what y is, okay? So now we've actually done this. We've solved this problem. We know that x is 3 and we know that y is 7. And I always do say one thing that's really nice about simultaneous equations when you're in a GCSE exam is that you can actually check your work. You can just take that other equation, you can check your answers, and you can make sure you've got it right. And it's always quite nice if you just get that feeling of like, oh, there's some marks, I've got that right. So always check your work, unless you are really limited on time in the exam, then don't. But checking then in equation 1, and it is important because we substituted into equation 2, it's important we check in the other equation. Okay, so we're going to check in 1 this time. So that's going to be 4 times x, that's 4 times 3, plus 2 times y, and y was 7. Hopefully that's 26, otherwise I'm not going to be very happy. So that's 12 plus 14, it is 26. Good, so that means we've done it right. Okay, so that's your whole overall method for how to solve simultaneous equations. There's quite a lot to remember there, so we're just going to go through it a few times and look at some variations. But before I do, does anyone have any questions for me? I feel like I've just talked at you for the last 15 minutes. No questions? Okay. And everyone happy for me to move on then? Yeah. I've lost you. I can't see where you are anymore, but okay, I can see some of your faces. That's nice. All right, I will continue on then. So I am now going to look at this one here is exactly the same technique. The only difference is that we've got subtract, so it's become minus 2y instead of plus 2y here, but it's almost exactly the same. I will just go through it with you just to sort of give you another idea of how we did it. Okay, so you can just see it all happen again. So step 1 was to number the equations. So there we go. We've got equation 1 and equation 2. That's a nice, easy start. Step 2 is to subtract one from the other. And you'll see here, if I subtract this bottom one from the top one, 7x minus 5x is 2x. Minus 2y minus minus 2y. Well, that's minus 2 minus minus 2. Remember, they become a plus, so it becomes minus 2 plus 2. So actually, that has now gone away. That's become 0. So that's why we're subtracting there. And then 22 minus 14 is 8. Okay, so looking much simpler to solve already. 2x equals 8, so that means that x must be equal to 4. So we've done part 3. Part 4 then is to substitute into any one of these equations. Last time I substituted into 2, so this time I'll do 1. So I'm now going to substitute into equation 1. So 7x, 7 times 4, minus 2y, don't know what y is yet, is equal to 22. 7 times 4 is 28. Minus 2y is equal to 22. And then 22 minus 28 is equal to minus 6. So now we've got minus 2y is equal to minus 6. So that means that y must be equal to 3. So we've got the answers x is 4 and y is 3. And finally, we should check our answers, which I haven't given myself a lot of space to do. I'll just come up here and do it in a different color for you. So checking then in equation 2, 5 times x, that's 5 times 4, minus 2 times 3 is equal to 20 minus 6, and that is 14, which is what we wanted it to be there. Okay. Any questions on that? No? All right. I'm going to continue on. So we've had a look now at a couple of examples where we can subtract the equations. And the reason why we can subtract the equations are because these are the same. And actually, what I haven't shown you is that you may find you've got something like this, like 2x plus 2y equals 0 or whatever, and then 2x minus 5y equals something else. And the things that are the same will be here. So they don't have to be there. They can be there. Exactly the same method. You would just subtract the one from the other and then continue following those steps. So exactly the same. Doesn't have to be that the two that are the same are here. Okay. They may be x's, they may be y's that are the same, but you're just looking for, have I got two that are the same? That's the kind of big thing you need to look for there. Okay. So the next kind of step, and it is really, actually, some people find it easier, is what if you have a problem where the signs are different? So the numbers are still the same, but the signs are now different. So you can see here, we've got plus 3y and we've got minus 3y. I'm going to do that in a different color, just so that, okay. So what happens here? So that subtracting step that we had before is not going to work because 3y minus 3y is actually the same as 3y plus 3y, and we would end up with 6y. And we wouldn't have got rid of the variable. We wouldn't have eliminated one variable. So that's not going to work. So we need to do something else. And that something else is simply just we're going to add them up instead. Okay. So if you have the same number, you've tried subtracting, it's not worked, you know you haven't messed up your negatives, because that's always the first thing to check. Try adding. It's just that you needed to add instead of subtract. And apart from that, all the steps are exactly the same. So we can just follow through exactly the same steps. Step 1 is to number the equations. Step 2 is to add them together rather than subtract them. So 4x plus 5x is 9x, plus 3 plus minus 3y is 0. They go away now. Okay, so that's become 0. And 32 plus 13 is 45. There we go. Okay. And then we're going to solve that. So now we can say if 9x is equal to 45, x is equal to 45 divided by 9, which is 5. So that's step 3. And then step 4, all of the steps are exactly the same now. So step 4 is to substitute in. I'm going to choose equation 1. Again, it doesn't matter. So 4 times 5 plus 3 times y. I don't know what y is. I don't know why I put a bracket there. Equals 32. 4 times 5 is 20. Plus 3y is equal to 32. So 3y is equal to 12, and y is equal to 4. So we have the answer, x is 5 and y is 4. So you can see there that really isn't any difference in that. It's just if the signs are different, we're going to add them. Okay. Any questions? No, sorry, it's not very interactive session today. I do apologize for that. Okay, let's clear. So I did put the steps there. There you go. Okay, so here we go. We've got one more. So I am actually going to give you a chance to have a go now at doing this, because I just feel like I've just talked at you a lot. So I want you to have a go at doing it yourself. So please feel free to tell me what A is first. You can write it in the chat if you want. You could always write it in the chat, but as a private message, so it's not going to everyone, which means that you will have a chance to have a go without it coming up straight away. So to find A, you need to do those first 3 steps. Fantastic. Okay, we've got a correct answer coming in. Well done, Katie. Well done, Favour. Excellent. Well done, Tabitha. Good. Got some correct answers coming in, which is awesome to see. If you've got A, feel free to go ahead and find out what B is and to check. Just realised I haven't actually done it myself. I did do it earlier, but yeah, well done, Katie. It's great to see so many people participating today, actually, loads of people here. It's fantastic. Great, well done, Favour. Correct, lots of correct answers coming in. Okay. I think, shall I start? Yeah. Yes, well done, Tabitha. Good. Okay, I will start going through the steps now as well. So I'm going to start by numbering them. If this is a new topic, if you've not done this before, it's quite a lot to get your head around. So don't feel like you have to have it all correct today. There's a lot of steps, there's a lot to think about. So what have we got here? So we've numbered the equations. I've got equation 1 and equation 2. That becomes more important in the next thing that we're going to learn. So there is a reason for doing that. Now, the signs are different. I've got plus 4b and I've got minus 4b. So because the signs are different, I'm going to add them together. So adding them together, 3a plus 7a is 10a, plus 4b plus minus 4b is essentially just 4b take away 4b. So that becomes 0. And then 48 plus 32 is 80. So we've got 10a is equal to 80. And that means that a then is equal to 8, because 10 times 8 is 80. So there we go. We've got a is 8, which I got lots of correct answers in the chat for. So well done. And then doing the last 2 steps, okay, substitute that into one of the equations. I'm going to choose equation 1. So I'm going to take this equation. We've got 3a plus 4b. 3 times 8 plus 4b is equal to 48. 3 times 8 is 24. Plus 4b is equal to 48. So 4b is equal to 48 minus 24, which is 24. And then 24 divided by 4 gives us b is equal to 6. Okay, so a is 8 and b is 6. And if you want, you can check in equation 2 there as well. So absolutely well done to everybody who had a go at that and got the correct answers. Great to see. Thank you for taking part. And I think we're ready to move on to, go back to Jack and Jill, because I want to just discuss the next thing. So going back to that problem that we were looking at, in this problem, we had these two equations. Equation 1 was 2w plus v is 5.5, and equation 2 is 3v plus w is 6.5. And what you'll notice here is that we don't have that situation where we don't have a w with the same number in front or a v with the same number in front, okay? W2, 2w, and 1w, 1v, and 3v. So because we don't have that, okay, there we go, I wrote that down. So, because we don't have that, what we're going to need to do is we actually just have to change one of the equations so that they match. So we can just literally take one of those equations and change it so that it does match, okay? And we can choose to either do that to equation 1 or equation 2. It really doesn't matter. Normally, it's just looking and deciding what the easiest one to do. So I'm going to go through this problem now, doing those steps. So here's our Jack and Jill problem. We've got 2w plus v is 5.5, and we've got 3v plus w is 6.5. The first thing I'm going to do is I'm going to rewrite them, because I don't like that the v's are diagonal and the w's are diagonal. I just don't like that, okay? It's just annoying. It will happen sometimes. We can just rewrite it. So I'm just swapping my v and my w around here. So we've now got v plus 2w and 3v plus w. Doesn't change anything in the equation. It's just easier to look at, okay? The next thing I'm going to do is I'm going to need to change one of these equations. I've numbered them, by the way. You'll see I've got equation 1 and equation 2. And now what I'm going to have to do is pick one of them, and it doesn't matter which, and change it so that either the v's are the same or the w's are the same, okay? So if I wanted to change it so the v's are the same, I would need to take this whole equation 1 and I need to multiply it all by 3 so that I've got 3v here. Or I could choose to make the w's the same by taking the whole of equation 2, multiplying it by 2 and having 2w here. I don't know which one I decided to do when I planned this lesson. It seems I planned to multiply equation 1 by 3, so that's what we'll do. So we're going to take equation 1 and we're going to times it by 3. And now my equation 1 has become equation 3. So I've changed the number because it's my third equation. So I've taken the v and I've times it by 3. I've taken the 2w and I've times it by 3. And I've taken 5.5 and I've times it by 3. Really important, you multiply every single term in that equation by the number you're multiplying by. You can't just multiply 1 because then you've changed the equation. If I times everything in the equation by 3, the equation is actually still the same thing. It's not changed, okay? So let's have a look at this problem now. So what I've got now is the problem 3v plus 6w is 16.5 and 3v plus 1w is 6.5. And I can literally follow those steps and solve it as before, okay? So those steps are coming up now. Number the equations, we've done that. Subtract one from the other. So I'm going to take equation 2 and I'm going to subtract it from the equation that is now equation 3. So I'm going to subtract. Why have I chosen to subtract? Well, because we've got 3v and 3v, they've got the same sign. So that means they need to be subtracted. So 3v minus 3v is nothing. That one goes away. I've eliminated v. 6w minus 1w is 5w. And then 16.5 minus 6.5 is just 10. So we can see now that 1 pail of water cost £2. Okay, so there we go. We've solved, I've written solve to find x. It's actually solving to find w this time, but there's really no difference. So now we're going to take that w and substitute it back into any one of the equations and solve it to find y. And we could choose to actually substitute it back into equation 1 if we want. Equation 1, I've forgotten, was v plus 2w is equal to 5.5, wasn't it? That was equation 1. You could choose to substitute it into that, or into that. It's entirely up to you. And I think that substituting into equation 1 is the easiest. It just looks easier than the others. So I'm going to substitute into 1. So we're going to have v, we don't know yet, plus 2w, we now know is number 2. And that's equal to 5.5. Okay, so v plus 4 is equal to 5.5. So v is equal to 5.5 minus 4, which is 1.5. So we had that 1 bottle of vinegar was £1.50. And 1 pail of water was £2. Okay. Now that we've done a few more, does anyone have any questions on this? Or would anyone like me to go through any parts of this a little bit more? No? No. Numbering the equations won't get you any marks. It's more for sort of keeping things in your head. Sorry, just for anyone on that, I realize if you couldn't see the chat, Katie just asked if you would lose marks if you don't number the equations. You wouldn't. That's more for just keeping things organized. The reason why we do it is so that we can sort of show the examiner what we're doing. We tend to write these little notes in the exam. So you might write like sub into 1, and that's showing the examiner that you're subbing the effect thing that you just found into that equation. Just makes it a lot easier for them to mark it. And you like it when they find your exam easy to mark, they tend to like you a little bit better, and that's a good thing. So by giving them a little note to what you're doing, just makes it much easier for them. Okay, just as a person who's done a lot of exam marking in the past, it's just a good thing to do, get into the habit of. Okay, so but yeah, good question. No, you won't. Why is the top equation named 3? The reason why that one we made it 3 is because I need to go back on the. I don't know how to go back on this without unsharing. The reason why is because, you know, we had that Jack and Jill problem that I looked at the beginning. I will just write out the 2 equations that we had from that problem were, if I can remember rightly, I think it was 1v plus 2w equals 5.5. And I think it was 3v plus 1w, something like that. Anyway, it might have been slightly different. And these were my equations that I called 1 and 2. But we couldn't solve like this because we didn't have any coefficients of v or coefficient of w that were the same. So I actually made a third equation by timesing equation 1 by 3. I times everything in equation 1 by 3. So I did 3 times v, which was 3v. I did 3 times 2w, which is plus 6w. And I did 3 times 5.5, which was 16.5. And this was my new equation that I made. So I called that one 3. So that's why that equation was called 3. And then I literally just rewrote this equation 2 underneath, because now I've got an equation with 3v and another equation with 3v. So I was able to solve equation 2 and equation 3 together. These 2 could be solved, but these 2 couldn't be solved. Equation 3 is actually an equivalent equation to equation 1. They are the same thing. There's no difference in it. If we substitute the v and the w that we got into here, it's the same as this. This is just like a less simplified version. So equation 3 is can be simplified to equation 1 by just dividing everything by 3. I don't know if that explains the question. The question was, why is the top equation named 3? I hope that explains it. Does it? Okay, that's good. Does anyone else have any questions? It's really good if you ask questions because it sort of clears things up about things that you don't understand. Okay, so I will do another example. I think I've just, here was just a quick summary. So I just thought I'd write a quick summary of what we did. So the first thing we're going to do is scale up each term in one or both equations to make the same number in front of either the x or the y terms the same. Okay, so that's that step that we just learnt. And then the next steps are simply to subtract if the signs are the same, or add if the signs are different. Okay, so those are those kind of first steps that we needed to remember. So here we've got another problem where we've got no matching coefficients. We've got a 6x and a 3x. We've got a 5y and we've got a 1y essentially. And so we're going to have to change one of these equations, okay? And again, it's entirely up to you. In the exam, you might choose to change it so that the x's are the same or to change it so the y's are the same. It really doesn't matter. It's up to you. Does anyone have any preference today as to whether I change it to make the x's the same or the y's the same? No. I'm going to go with x's then. Okay, so I'm going to skip out step one. I'm not going to number the equations today just to show you that it's not completely essential. All right. So I'm going to go straight to step two and I'm going to scale up so they have a matching coefficient. So that means that I'm going to choose to multiply equation 2 by what number? I need to multiply it by. If I'm going to get the x's to be the same. 2, yeah, okay. If I multiply it by 2, the x's will be the same because this will become 6x. I could also multiply it by 5 and make the y's the same if I wanted, okay? So entirely your choice there, but multiplying by 5 just seems, well, I'm going to do 2. It's easier to multiply by 2 than 5. So I'm going to multiply this equation by 2 and I'm going to get the new equation. And I'm going to write it here, 6x plus 2y, I realize I might not have space to write it here, equals 48. Okay, so really important, remember to multiply every single term in the equation. I now have this equation and this equation, and what I'm going to do is I'm going to rewrite this equation exactly the same, just above it, because 57, it's just easier to subtract if they're one above the other like that. So rewriting it above there just makes it a little bit easier to look at. Now I can see that when I subtract, this 6x is going to go away because they're the same. So 6x minus 6x goes away. 5y minus 2y is 3y. 57 minus 48 is 9. Yes, it is. Good. Solving them, we've got y is equal to 3. So there's our first problem. I've swapped these around, and this time I found y instead of x. That will happen often, doesn't matter. Okay. And now I'm going to substitute in. This is where numbering them would have been useful. I'm going to pretend I called that first one 1. Okay. And I'm going to have 6x plus 5y, and y is 3. Is equal to 57. So 6x plus 15 is equal to 57. 6x then is equal to 57 minus 15, which is 42, and x is equal to 7. Okay. And my last step, I should check the answers. So if I was checking, I would check in equation 2. Again, you don't get marks for this part. It's just for your own kind of personal knowledge that you've done it right. Okay. If you had time, maybe leave the check to the end when you finish the whole exam. and you're coming back, like looking back over the paper, you could do that check then. Very easy. Any equations that you've solved, substitute the number back in and check that you got it right. Okay, so 3 times 7 plus y, that's y is 3, is equal to 24. 3 times 7 is 21, plus 3 is equal to 24. So I can sort of almost feel confident that I've got the right answer there. Where's the, I minus the 15? Where did the 15 go? Where's the 15, Shelley? Oh, here. Yes, yes, I have. In this step here, I have subtracted 15 from both. So 57 minus 15 is 42. Yeah. Sorry, that's just me solving the equation really quickly. I'm not showing all my steps. Any other questions? Okay. Please do tell me if I'm going too quick and skipping out steps and making it confusing, just let me know. I'm just trying to sort of get through as much as possible so we can learn as much as possible. There's one more that I wanted to look at. I might just do one more. Kind of wishing I'd moved those steps out the way so that I wonder if I can just do this without having those steps there. A bit more space. There we go. Okay. So we'll just do this one more time and then we will look at the very last thing and then hopefully we'll have time to have done everything today. So I'm going to number them 1 and 2. And now I'm going to choose to, I could choose to change it to be the x's the same. I'm going to choose to make the y's the same because I did the x's the same last time. So I'm going to multiply this whole second equation by what number? Yes. A whole second equation by 3, just checking everyone's listening. So 3 times 4x. Oh, I won't need that yet. Now I need to rewrite my equation here. Okay. 3 times 4x is 12x. 3 times minus y is minus 3y. 3 times 5 is 15. Okay, so there we go. We've just multiplied everything in the second one by 3. I don't need to change the first one at all because I now have 3y here and I've got 3y there. So I'm just going to rewrite. Now, here's a point. Oh, actually, I'm not going to do that. What I was going to say is that sometimes it's a good idea to write it below. If you're going to subtract, looking at this equation and noticing, and that's actually become equation 3 now, hasn't it? So it's different to this. But looking at this equation and noticing that the numbers are smaller than this one, if you were going to subtract that, you would end up with negative numbers. So sometimes it's a good idea to write it below, and then you can like just not have to deal with negative numbers, which is quite nice in your exam. So that is a good hint, but we don't need to worry about that because what I've just noticed is we have different signs. And if we have different signs, we don't have to subtract anyway, we'll be adding them. So I'm going to be doing 2x plus 12x, which is 14x, 3y plus minus 3y, which is 0, and 13 plus 15, which is 28. So 14x is equal to 28. Divide then by 14 on both sides. X is equal to 2. Substitute that in. I'm going to choose equation 1. Sub that into equation 1. We have got 2 times 2 plus 3y is equal to 13. That's 4 plus 3y is equal to 13. And then yes, here we're going to subtract the 4 from both sides. So minus that 4 from both sides, which is the step I sort of skipped out last time. Apologies for that. 3y is equal to 9, And so y is equal to 3. I'm running out of space, but there we go. And finally, I'm going to choose orange to do my check. And I'm going to check in equation 2 because I substituted into 1. So 4 times 2 minus y, which is 3, is equal to 8 minus 3, which is equal to 5. So we've got that right. Any questions? Apologies if I'm going a bit too quick. Okay. And let's just look at the very last step. So we've actually managed to get through to like the hardest style of simultaneous equations that we were going to look at today. So that's really good. And that's just something like this, where you cannot just change one. So I cannot say, right, if I times 3x by something, I'll get to 4x. Or if I times 3y by something, I'll get to 4y. So in this case, I'm going to actually need to change both of the equations rather than just one of them. Okay, so the only extra step here is that just doing 2 changes to the equations. So step 1, number the equations. Okay. And step 2 is to multiply them. Now, if you've got this situation where you have to multiply both equations by something, the easiest thing to do is to take the first one and times it by the first variable of that one. So I'm going to times all of this one by 3. And then to take the second one and times it by the first variable of this one. So I'll times all of this one by 4. So I'm literally just going to take those numbers and swap them over and multiply. And that will give me the same number here. And that will always work. Okay, so it's just a sort of easy trick for this if you're not sure what numbers to multiply them by. So I'm going to do 3 times all of equation 1. That's 3 times 4, 3 times 3, and 3 times 19. So I'm going to rewrite all that now. So 3 times 4x is 12x. 3 times 3y is 9y. And 3 times 19 is 57, I think. And then I'm going to do the same thing with equation 2. 4 times 3x is 12x. 4 times minus 4y is minus 16y. And 4 times 8 is 32. Yes, okay. So by choosing to cross multiply this with this and this with this, all I've done is I've made sure that this very first term is the same. And that will always work. So it's just a handy little trick. And now I have equations 3 and 4. And I'm going to work with these 2 equations because they are now have the same variable. Oh, that's a really good question. I think you are. Can I check that and answer that next week? Katie just asked if you're allowed to use different color pens, which I always do in my teaching. Actually, no, I don't think you are, because I think there's a strict thing about using either blue or black ink. So I'm assuming that you wouldn't be able to bring other colors in. You could maybe have a blue and a black pen and work with both of those. I don't think that would be disallowed, but you definitely wouldn't be able to bring in like red or green or anything like that. So I think also in exams in the UK, I'm not sure about international exams, I'll check. They've stopped you highlighting questions now. I will check that, but I think that they don't let you use highlighter anymore either. So let me get back to you on that, Katie, but good question. Okay, so let's solve this before the end of this session. So we have changed both of the equations this time to rewrite them with the same number in front of x. They are both positive. So that means that I can subtract. So 12x minus 12x is just 0. Be careful with negatives here. We've got 9y minus minus 16y. 9 take away a negative 16 is actually the same as 9 add 16. So just being aware of your negatives there, 2 negatives, same as adding. So that's actually going to work out to be 25y. 57 minus 32 is 25. Okay, it's getting late in the day. I had to use my calculator for that bit. Y then is equal to 1. 25 divided by 25 is 1. Okay. And step 4 was to substitute into, and at this point you can choose any one of your 4 equations. You've got 4 equations here to choose. I'm going to just stick with equation, well actually I'm going to go with equation 2. It looks a bit easier, doesn't it? Substitute into equation 2. So I've got 3x minus 4y, y is just 1, is equal to 8. So that means that 3x minus 4 equals 8. Add that 4 onto both sides, it's a minus, so I've got to add it to both sides this time. So 3x is equal to 8 plus 4, which is 12. And so finally dividing then by 3, we've got that x is equal to 4. Any questions? Yes, you can always underline any part. Yeah, absolutely. I'd say it's a really good idea to underline important parts in the question as you're going through. You may be able to use highlighters. I will check that for you because that's what I would always have said to do, but I had a feeling that they stopped it with some exam boards, so I'll check for you. Okay, any questions about where y is 1 and x is 4 came from? Bless you, Tabitha. Right. One last thing I just quickly wanted to show you, and I'm going to have to change what I'm sharing here, so I'm just going to get, if I can, is how this relates to graphical and a graphical problem. So let's go to this one that we've just done. What I'm going to do is I'm actually going to stop sharing or do a new share. Hang on, I'll get the tab open first. I thought I'd already typed this in, but I seem to have lost that page now. So I'm going to share this with you. So hopefully now you'll be able to see a graphing calculator come up. Can you give me a nod if you can see it? Excellent. Okay. So you can hopefully now just see a big empty graph at the moment. And what I'm going to do is I'm just going to type those 2 equations in that we have just solved. So we just solved the 2 equations. 4x plus 3y is equal to 19. So you can see that's the graph that relates to that equation there. And I'm going to type this in, 3x minus 4y is equal to 8. And that's the graph. So the red graph is my first equation, and the blue graph is my second equation. And we solved it, although I've just got rid of what we found the answers to be. But hopefully we found that the answers were this coordinate here, which I can click on is 4 and 1. So hopefully we've got x is 4 and y is 1. So that's actually how you solve them graphically. So if you're good at drawing graphs, it's really easy to solve them graphically because you can literally just look at where they cross over and get the coordinates. The x coordinate gives you the x value, the y coordinate gives you the y value, and you've got the answer. So when we come to doing graphs, we'll look at this a little bit more, but hopefully that just shows you where, like, how this will relate to that third method, which was solving them graphically, and just sort of shows you an idea of how this works. Okay, so these are 2 linear equations. That means that they're both straight lines. They'll go on like that forever, basically, but they cross over at that coordinate. X is 4 and y is 1 there. Okay, any questions on that? This last little bit.